Good afternoon, ladies and gentlemen. お待たせいたしました。Technology Track Tech-07 ネット選挙クラウドオバマ大統領選挙の事例データ解析からネット募金までを開演いたします。講演は Amazon Web Services Solution Architect Senior Manager Mr. Miles Ward. Mr. Ward?
おはようございます。私の名前は Miles Ward さん。私は大きい、おかしい、オタク。and no more Nihongo. I'm bad at Japanese. ごめんなさい at the bad Japanese. I'm happy to present today about Obama for America, an amazing example of what you could build on Amazon Web Services. So what I will cover is first the technology system, the design of that system, and the choices that the Obama team had to make as they made the decision to build on AWS. I'll also look at the services from AWS that they used and the lessons that they learned as they deployed such a powerful and successful technology tool. We'll also make sure that you learn some tricks to take home to build something as effective and powerful as this system. So a little primer, otaku, I'm a little bit of a nerd. It's the only way that I could work with this kind of geeky technology team. I was a volunteer. So the laws in the United States about companies participating with political campaigns required that I was on vacation. So this is a presentation about my vacation. So other times when I'm on vacation, I play tuba, I play electric sousaphone. So I'm kind of a weirdo. I fit in with this Obama team. So let's describe what the problem is. What's the challenge? Why is this a good example? So we're going to build a system as a part of this campaign to raise $1 billion. That's how much money was donated into the Obama campaign over the course of the election. We'll build 200 different software applications, totally new tools, no old code, brand new greenfield software systems. We'll build in an environment that we have to cover huge new data from Facebook, data from Twitter, data from social media, data from voters. All of that has to be used in brand new analytical approaches, new kinds of analysis that have never been tried before. This is fun. This is exciting. This is what technologists want to do. This is the good stuff. What's bad, not as fun, is you have a very short period of time to do it in. Only 6 months, really, of functional work to design and deploy the system. You also have a very small amount of money. Every dollar that you spend building this system, you cannot spend trying to elect the president. So we had to be very conservative with money. Most of the developers of this system were volunteers, so not paid, no money. And so you have to learn how to use volunteer labor instead of full-time paid 9-to-5 developers that are professionals. The average age of the software developers is just 24 years old. So this is, in many cases, the first big thing they've ever done. The tech team knew that these were the constraints. And so they got a small group in the middle, the center of the team, the DevOps team, that built a core set of tools that allowed all of the volunteer developers to succeed. And it's a bunch of weirdos like me. Lots of beards. So that's me. That's the CTO. That's Harper from yesterday. And all of these guys now do very, very advanced things with cloud. Leo and Holcomb, they both now work for AWS. They're solutions architects too. Oh yeah. Facebook, startup, Sonos, NASA, Facebook, right? Netflix is from the security team. Very, very high-end technologists came out of this practice. And it's their success that allowed the Obama systems to do all of the amazing things that they did. Their environment was messy. It looks like a bad kid's, like a college dorm room. You would tell someone to clean this up, right? Noisy, lots of sugar, lots of kids trying to build a system. How do you succeed when these are the sort of raw materials? Very different than nobody looks like this. None of these. So, but very important professionals involved. So that's Eric Schmidt. He's the CEO of Google. He was a volunteer too. So he was the Google guy, and I was the Amazon guy. So that's me over there. And that's Harper in the back. Dylan was engineering lead, developer lead. Looks like Santa Claus. Ho, ho, ho. So this team built 200 different applications. I'll explain some of the things that those applications did. So one system called Call Tool, a part of the American political process, you are not automatically registered to vote. Not everyone is allowed to vote. So you must fill out a form in advance before Election Day that tells where you live so that we know where you vote. Super important that we call new voters to encourage them to register. So we had thousands, tens of thousands of volunteers, not technologists, people who just want to make a phone call. And those technologists, those non-technical people, they used Call Tool. It's a mobile app for the phone, and you just say, I want to talk to the next most important person in the United States. And you call on the phone and introduce yourself and encourage them to either fill out a survey, get data like polling data, new information for the analytics systems, or to go register to vote, or on Election Day to go vote. That system is constantly optimizing exactly the most important person to call next. So out of the 10,000 volunteers, they're not calling the wrong people. They call the most important people. Same with Canvas. If you're going to walk around a neighborhood introducing yourself as a volunteer, hi, you should come vote, we put a map so that you walked easily from potential voter to potential voter. And if instead of waiting, there's a database that shows whether you've registered or not, but that database is only updated once a month, which is too slow. So we checked Twitter and Facebook. If you tweeted, I registered, then we would take the flag off the map. We do that every 5 minutes. So it's a much more efficient system for sending voter volunteers and using their effort. Hundreds of applications like this. There's numerous examples. Because of these systems, and because of the president's policies, and because of the hard work of everybody, Obama won. Woohoo. So, in order to get to winning, we knew that we would have huge spikes in traffic. Election Day was going to be an incredible load. There were, from 0 participants in the campaign in January, there were over 600,000 people volunteering on Election Day. Amazon only employs 60,000 people. So I need a technical system that works 10 times as big as Amazon for Election Day, but only for 1 day. And if you're late, well, it's not useful. If it's not done by this day, we can't use it. You can't move the due date out. It's a requirement. It would take an act of Congress to ship 1 day late. So every chart, all the different charts look like this. The web traffic, the database load, the incoming requests, new users, they're all huge spikes on Election Day. So how do you build a system that does this? Scott Vanden Plas, senior architect, designed the implementation for this system. He tweeted an important statistic here, 8.5 billion in-queued events just in the last week of the election. Huge technology system. So how do you do this? We talked with them a year before the election, and their first thought, the first idea, was that they would use Amazon. They could buy the computers from Amazon, and we would even ship it for free. But they were very worried that with so many computers, that they would spend too much time managing computers and not enough time building all of this software. They sent us an email that asked for what we usually say are the benefits of cloud. They asked, please, we don't have any money at the beginning of the election, we have it at the end. And that's when all our traffic comes. We want to be able to not have any upfront payments. We also want to spend as little money as possible. We really need to only be paying for exactly what we use. We know that Amazon or any provider would be too slow, so it has to be self-service. Our software has to be able to build our infrastructure. We know that when we're done with the election, we won't need any of this anymore. So we're just going to turn it off. So we must be able to scale up, but we also must be able to scale down. And we have to be done yesterday. Gotta go. So they asked us for this stuff, and we said, oh, this is what Amazon does. This is how we do it every day. This will be easy. So we built this. And this website works. You can go visit. It makes the map something you can zoom in so you can read all of the details of how each piece was built. But I'll show a couple quick examples. First piece, we use the basic best practices from all normal AWS systems for the last 4 years. There is no new rocket science here in the design. They just had a lot of systems. So we use auto-scaling groups. We use elastic load balancers. We use RDS. We use multi-AZ. We use security groups to protect the infrastructure. Most of the time we had Elasticache, Memcached clusters in between the two. We also used SQS. We'll talk a lot about the loose coupling in this design. We also built huge analytics systems, 528,000 IOPS of database performance in a cluster compute, which now you can run here, in a cluster compute data warehouse. We also ran over 200,000 IOPS in DynamoDB, and we'll show that example in a bit. We built super critically, probably the most important architectural choice in this design was that we built an API to abstract service providers that gave the campaign data from the developers building applications that consumed data. So a great example is payments. We're going to collect $1 billion. So if we have one payment processor, if that payment processor goes down, we're in real trouble. We need redundancy from services across multiple payment processors. So that we used 5 outside payment processors, and we even got pissed off and built our own on AWS, PCI DSS level 1 compliant payment processor built just for this campaign. Those 6 processors, if each application that got developed needed to integrate with all 6, that's 6 times 200 applications, 1,200 integrations. That's too much time. So we take all of the logic for the integration and put it in the middle in a central API, an API. And that makes it so that the developers just connect to payments, one API on our central system, and that system connects to each of the payment processors so that if we have to turn one off or replace one or change it out, we do that in one place instead of 200 different places. Makes it much more efficient. We used a huge variety of software tools, mostly because we have volunteer developers. So when I start a company, I choose what software I want people to use. If you apply, I know Java, and I say, well, we build in Ruby, I won't hire you. If you're a volunteer, you say you know Java, great, go work with the Java guys and figure out something smart to do. Help us build something. I don't have any time to retrain volunteers. So we have to use and reuse open source technologies of dozens of different kinds. 11 different structured storage systems, different databases. We have DBAs that know Postgres, so fine, we better put Postgres behind something. We have DBAs who know MySQL. Well, let's put them in front of RDS, make sure they use that. We also had different software tools that relied on the features of different databases. So some systems were very focused on high performance KV, key value store systems, so that's DynamoDB. We had other systems that were dependent on very complicated query patterns, so they'd use SQL Server from Microsoft, all sorts of tools. Also built in many different development languages. PHP, Ruby, JS, all the different frameworks for development. Objective-C, you have to develop for each of the mobile interfaces. Designed for tablets, designed with reactive design, so you build one user interface for all the different devices. Very complicated development effort. We built hundreds of applications. There are only 200 days between the beginning of the development and election day, and we released 200 software applications. That's an application every day. Super hard. Muzakashi. So they were worried when they made the choices about this design. We'll use lots of different languages, Tagengo, polyglot development. We'll use cloud. They were worried that those choices had risks. If we use so many different languages, it will make ops super hard. If we use cloud, maybe we won't have the control to fix things if something breaks. If we use a service-oriented architecture, maybe it will be too complicated for our developers. They won't understand how to build. What they found was that these risks didn't come true. They didn't happen. And they got really big benefits from each of those choices. So because they had multiple different programming languages, if there was a problem with one language, it only affected a tiny part of the system. It meant that if you had to redirect efforts to fix that problem, you were much more able to solve it quickly. It didn't affect the whole system. They found with cloud, they were able to move super fast. It was super cheap. They were able to get systems on demand. They had over 1,600 EC2 instances to power this system. Huge system. They also earned huge benefits from redundancy because of the service-oriented architecture. We'll talk through that pattern in a bit. So for SQS, how many folks use SQS? Maybe just me. So if you're not loosely coupled, if you don't have a buffer between the front end and the back end, then you just aren't broken yet. Loose coupling is a requirement of a system that is flexible around change. But it also makes your system dependent on the queue. So you can build a queue. Everybody knows ActiveMQ, RabbitMQ. There are open source queue software. That software is good software. But if you choose to use that on EC2, you inherit responsibility. You own that product. Now instead of 200 software applications to build, you have 201. You're also in charge of the queue. They didn't know how many messages they would send through the queue. We ended up doing the math after the fact, and they needed 12 huge EC2 instances, CC2, 8x large instances to run their queue. But they couldn't have predicted that in advance. They don't know. Maybe they need 600. Maybe they only need 2. But it's really hard to change the size of a queue in the middle of using it. And it's so foundational to all 200 applications. It was really important that they were able to use SQS. And they learned that pattern and applied it across lots of different services. They don't have any time to waste investing the best engineers on problems Amazon has already solved. We know how to build SQS. It works great. It works great for millions of customers. So they did this with many AWS services. They used Elastic Load Balancer instead of building their own load balancers. They used Elasticache and RDS and Cloud Search and Route 53 and S3 and CloudFront and DynamoDB and many, many others, RDS. If you choose to use open source software or closed source software to replace these products, you are choosing to invest the time and focus and expertise and money and due diligence around risk and all of the hard work that makes them your product. You have to be as good at running these as Amazon is. That's hard. And so this team chose to use our tools to make them get done much, much faster. A great example of that, I wrote the white paper for MongoDB. I know exactly how to use MongoDB. We have systematic instructions on building high-performance clusters in MongoDB. But it's 13 steps just to launch one MongoDB instance. I did it as fast as I can go. And it takes me 12 minutes to launch the cluster. With DynamoDB, with one line in the Boto CLI, I deploy the cluster and write 1.6 gigabytes of 1K objects in 8 minutes. Right? By the time I'm done doing these writes, I haven't even finished starting the MongoDB instances. So sometimes there's a time value of money. You have to get systems built very quickly in order to be able to make them valuable. So we also had lots of other things we couldn't predict. There's a huge storm. This is a picture of the wind in US East. This is the center of the storm, and this is where US East is. Amazon systems did not break. We had no failures associated with the storm. The storm didn't affect Amazon infrastructure at all. But if you're the boss and you see this picture, you might want a backup. Kind of important to have a failure plan to ensure that you can recover if this storm is even bigger than it already looks. It was so important they sent us a cake. Said, don't screw this up. So we had spent 3 months building the infrastructure in US East. But this storm wasn't going to wait 3 months. So we took 9 hours to build a copy of the critical components of that infrastructure in US West. That's not just standing up all the computers and the queues and the networks and the configuration, but it's also moving 27 terabytes of analytical data. Very important. It doesn't matter. All of us can be AWS Solutions Architect Maximum Expert, and if we go into the console and we do this with a mouse, you will never get it done in 9 hours. It's too many clicks. You can play the console like it's a video game, and you'll never go fast enough. It must be programmatic. It must be code. So they used CloudFormation. They used Asgard from Netflix. They used Puppet throughout these systems to ensure that they could build a copy on demand. They also used Tsunami UDP and CloudOpt and other WAN optimization technologies to move the data to ensure they got that done super fast. They also used an enormous amount of caffeine because this is a late night. For Tsunami, each EC2 instance, this is an M2 4x large instance, across the continent moved at almost 500 megabits a second, 476 megabits a second. So we start a cluster of those on either side and ship the data. Makes it get done very, very quickly. So what did they learn? What are the new ideas that you can take and use? They built this practice called game day. Game day is a model where you use staging, a copy of production. And let's say this whole half of the room, in game day, sorry, gomenasai, you're the bad guys. In this whole half of the room, you're the good guys. So you'll build staging, and then you give keys to the bad guys. And they go break staging. They delete EC2 instances, like Chaos Monkey from Netflix. Or they rename SQS queues, or change DNS, or screw up an elastic MapReduce configuration, change code. Then the good guys have to fix it. Because we're talking about very young developers, this may be the first time they've ever really had to fix something under pressure. So it's important that they practice first. And you learn, it's one thing to sit at a table and discuss, here's how we'll fix it, it will be fine. It's another thing to actually have it break and have to fix it right now, while people are watching, while there's noise, while you're up late. So game day allowed them to practice in advance using AWS to ensure that no matter what broke, they were always safe. And they used the game day they called playbooks, which are the list of step-by-step instructions on how to fix what was broken when they lost EC2 instances or they'd have data that got backed up incorrectly. There were lots of problems that this system allowed them to save, allowed them to survive. They also took huge value from loose coupling, from the separation of the front end and back end tiers. So an example, during the vice presidential debates, so there's Obama and Biden, so it's Biden's debate. During those debates, lots of people are watching the debate on TV, so there's lots of donations, lots of money. So during the debate, donations were actually over $400,000 a minute. So the systems that process those payments, super important. You can't turn those off. We're making the big money. You can't disable those kinds of systems. You certainly can't turn off the database. That would be crazy. Oh, kashi. But that night, Relational Database Service, RDS, released provisioned IOPS for RDS. So they made RDS databases 10 times faster than they were the day before. We've got to have databases that are 10 times faster. That's an important improvement for the whole system. Because we used SQS, every payment transaction entered a queue and waited there before a worker node dequeued it and ran it through the payment database. So we can change the database out whenever we want. So we did. In the middle of the VP debate, turned off primary master database, deleted it, restored from a copy onto provisioned IOPS, and reattached the worker nodes to that provisioned IOPS RDS instance. No downtime, continued to process at $400,000 per minute donations. That's what loose coupling allows you to do. You don't care when somebody unplugs the wire. You don't care when you need to make a change. If that was tightly coupled, that's 404. That's downtime. Another example of that is many of these systems are websites or web applications or mobile applications that connect over the web. So those systems, while very powerful if they're connected through EC2 and auto-scaling and dynamic content, the last thing that we can afford is downtime. Can't have the systems turn off. So every day, they took a static copy of the websites, put it in S3, and could redirect DNS to those S3 copies if there was a failure. So now instead of 404, broken, the President Obama doesn't know technology and is super dumb, instead, the button doesn't work. Or the submit form says, oh, please try again later. Looks very professional, just like this. Looks very much like it's still working. And at super cheap, because S3 is only 9.5 cents a gigabyte. The whole production website system cost 18 cents to store in S3. That is a good spend. Your boss will say, yes, spend the 18 cents, please. So they also learned through each of these different projects, 200 different applications, that cloud really does work. Cloud, they made a big bet. They trusted AWS to deliver when they needed the systems to work. And the system worked. The president won. He's the president. So they're very excited to use, as each of the different volunteers and engineers move forward, they're all now building startups and working at great companies, and they're all using AWS in their new projects because they have a lot of trust built on the success here that I think you can learn from too. So what does President Obama want you to do next? Because he's very excited about technology, very excited about cloud. What you might want to do next is to learn more from these great engineers. So one example, some of the software that they built is now being open sourced. So this is a voter registration application written in Ruby on Rails on GitHub public. You can see the real code that they use to build this system. Learn from their patterns, learn their examples. I also really recommend this weekend, Saturday, registration is already full, so no one else can attend, but we'll do more of them in the future. We are going to do game day. So you can use examples from your systems, create a copy in AWS, and then break it. Learn what happens when it breaks. Learn how to fix it. It's a huge, huge advantage as you do real production work on Amazon Web Services. Thank you very much. ありがとうございます。